Hello and welcome to the University of Exeter Engineering Masterclass. You are now about to watch the Engineering Masterclass produced by Mohammed Hassan Khanjapur, who is a PhD student studying renewable energy here at the University of Exeter. The Engineering Masterclass will explore his research in tidal turbines, which can be used in seawater desalination systems, to give you a flavour of the sorts of academic research carried out in the discipline and the kind of topics you might want to study at university.
Hello everyone, welcome to this presentation. Today we want to know if it is possible to convert seawater to fresh water by using the energy from the sea. What do you think? Do you think it is possible? Now you have 2 minutes to think about it and write down your ideas. Yes, it is possible. Tidal turbine can be used to power reverse osmosis desalination systems from movements in sea. We have 3 questions here. We want to answer them. First, what is the reverse osmosis desalination system? What is the tidal energy? What is the tidal energy reverse osmosis desalination? And be careful, we have 4 keywords here. We have to learn them. Desalination, reverse osmosis, tidal turbine, and tidal energy. I will explain all of them in this presentation. Water. Why water is very important? Why we need to make more fresh water? Because water crisis is a problem from which many societies are suffering, and it is expected to get worse in future. You will be surprised if you know that even countries that are currently rich in terms of water will face water shortage in future. That's why we are seeking new technologies in engineering to overcome this problem. Desalination. What is desalination? Desalination is a process that removes salt and other impurities from seawater. There are different desalination technologies to produce fresh water from seawater. If we find an affordable way to desalinate seawater, everybody can have enough to drink. Right. One of the common desalination methods is reverse osmosis. You can see a schematic of a reverse osmosis desalination unit here. Reverse osmosis is a process where pressurized seawater flows through a filter, separating fresh water from saline water. By adding an external pressure to one side of the filter, clean water will flow to the other side. The product of the reverse osmosis process is fresh water and the brine with high salinity. For providing the required pressure for reverse osmosis filter, we need so much energy. Most of existing desalination plants in all around the world are using fossil fuels, which causes global warming. That's why we need to find better options. We need to find clean, renewable energy. Tidal energy. Tidal energy is energy powered by the natural rise and fall of ocean tides and currents. It is renewable source of energy. It is environmentally friendly, at least in terms of emitting zero greenhouse gases. Tidal energy is predictable, and also it doesn't take up that much space. Actually, we don't need to use our lands to produce energy. Tidal turbine. Tidal turbines generate energy from currents in much the same way as wind turbines. You may see wind turbine around your city or in movies. In same way, tidal turbine can convert tidal energy to kinetic energy, to useful energy. Wind turbine convert wind energy to kinetic energy, to useful energy, to produce, for example, electricity. When we put this turbine in a sea, we can produce kinetic energy which can be used in desalination system. You remember that in reverse osmosis desalination system, we need energy. So we want to provide that energy with a turbine, with a tidal turbine. Finally, we can combine reverse osmosis desalination unit with a tidal turbine to make fresh water. As you remember, reverse osmosis desalination systems need too much energy. A tidal turbine can be used to provide that energy. When we put a tidal turbine in a sea, it can convert movement of the water to a useful energy. With that useful energy, we can power a pump, and with a pump, we can provide the required pressure to reverse osmosis desalination system for making fresh water. So, problem solved. Yes, it is possible to make fresh water from movement of the sea. You can find so many other challenges, other problems can be solved by engineering. You can discuss with your teachers, your parents, and find other problems which can be solved by engineering. I always say that engineers are creative problem solvers. Thank you.
Hello guys, my name's Alice Parry and I'm a first year theoretical physics student at Durham University. Today I'm going to be giving you an insight into what studying physics is like at uni, the general structure of a physics degree, and I'm going to show you what a typical weekday in my life looks like. I'm from a place called Abergele in North Wales and I went to Ysgol y Creuddyn before coming here. I studied chemistry, physics, maths, further maths and Welsh Baccalaureate. I applied to study physics at Durham as I really liked how the city felt and I was attracted by the flexible degree structure. Durham is small and very beautiful with plenty of things to do at all times of the year. Durham University is a collegiate university split up into colleges which are spread over the city. My college is St Cuthbert's Society. The Durham physics degree is either 3 years for a bachelor or 4 years for the masters. The teaching varies between lectures, tutorials, supervisions and practicals, with the 4th year in the master's programme being mostly a research-based project. As you can see, you can choose from a wide range of degree types, each depending on your choice of modules. In the first year, the main module is Foundations of Physics 1, which provides a good base for the other years. Discovery skills in physics includes labs and programming, and then we have to take a pair of maths modules, which can either be single maths A and B, or calculus and linear algebra. I decided to take calculus and linear algebra. Then we have one optional module in the first year. I decided to pick analysis. They are all assessed throughout the year using formative assessments and then by summative exams or lab reports at the end of the year. In the second year, there are still some core modules as you can see, but you have more optional modules. For me, I will have to take the Theoretical Physics 2 module in order to continue on the Theoretical Physics degree. In the third year, the modules start to become more particular, with opportunity to choose very specialised modules in really cool things such as condensed matter physics and atomic physics. From my knowledge, as I said before, the 4th year mostly consists of research-based project, but there is huge freedom to explore many areas of physics, from the study of how physics applies to biological processes to advanced quantum physics. I will now play you a video of my typical weekday in university. I hope you enjoy it.
So my day starts, I wake up about 8 o'clock, I lie in my bed for about half an hour and then I go and have some breakfast. I like to start the day by opening the window, getting some fresh air and looking out to see what the weather's like. I then get out of bed, go to my sink, splash some cold water over my face to wake myself up, and then I walk to the kitchen to finally get some breakfast. I thought I'd show you guys what the weather's like today. It's pretty sunny. It's not usually like this in Durham. It's usually raining. Today I had fried egg on toast. As you can see, one of the eggs didn't want to behave, but it was still nice. I then head back to my room, make my bed, and then hop in the shower. Just before 9 o'clock, I open up my laptop, find the relevant lecture for that time. Today at 9 o'clock I had Discovery Skills in Physics, which was a lecture about error propagation and in particularly how to plot good graphs and the least squared methods, and also we were studying residuals as well. How it works during coronavirus is that the lectures are pre-recorded, and then if you need any help during that allocated lecture slot, you can join the live office hours and ask the lecturer any questions that you may have. If I've learned anything in uni yet, it will be that analysing data and error propagation is very important in the physical sciences, and particularly in physics. After finishing that lecture, I got up the tutorial problems for this week. I had a tutorial at 10 o'clock in person, so I wanted to go through the questions to see if there's anything that I might struggle with and have questions about. I then leave to walk to my lecture. It takes about 15 minutes to walk there, and I like to appreciate Durham's natural beauty. Just to let you guys know, so what tutorials are like small group teaching. So we're in a group of about 10 people, and I have 4 tutorials a week, one for each module apart from one, because my labs module doesn't have a tutorial. We have laboratories for that, which is usually 3 hours every Friday in person. The tutorial finished slightly late, but then I headed back to my accommodation and put my clothes in the laundry to wash. I then went and had some lunch before a busy afternoon. What you see now is my practical book, which contains data and information about experiments that I've done in my weekly practical sessions every Friday from 2 till 5. I had a lab book feedback session the next day, so I wanted to make sure that everything was up to the correct standard. I then went back to my room and finished off the lectures for the day. On this particular day I had some calculus and linear algebra lectures. How it works is that they're all pre-recorded and I have to complete the set number of lectures for that week, in that week. In calculus we were looking at double integrals, in particularly y-simple and x-simple regions. And then in my linear algebra lectures we were looking at spanning sets and linear independence in Rn. After finishing my lectures at 4 o'clock, I then went for a run around Durham with a friend, and then had some food, and then got ready to go to the library. I then headed off to the library for a few hours, where I stayed there from 6 o'clock until 10:30, and then I came back and chilled until about 12:30. And that's my typical day.
So far, I feel like university has been both challenging and fascinating, with the teaching being very dynamic and interactive. My number one tip would be to get into a routine and make sure you complete everything on time, but also to ensure that you take time to relax, do sports and be with friends. Here at Durham, there is an abundance of societies and sport teams, and I have made sure to take advantage of all opportunities I have been offered so far. I hope you guys enjoyed this little video, and I hope to see you in the future. Good luck with applying to university, and I will now pass you back to the host.
Gwerthfawr tu hwnt, dwi'n siŵr. What an insight those masterclasses were. Ac mae'n werth i chi fyfyrio arnyn nhw. You now have 15 minutes to reflect on both masterclasses. Time to think about which subject you preferred and why. Can you see yourself studying either of those disciplines at university? Wnaethon nhw gadarnhau mai dyna'r pwnc I chi. Remember that realizing something is not for you is just as valuable as finding something new to consider. As you work through the reflection template, think about what you've learned, what you liked or maybe didn't like, and how what you've seen has changed your thinking about what course you want to study. Cwestiynau mawr, ond peidiwch â phoeni, please don't worry. You don't need to have all the answers now, but reflecting like this will help you start to decide what subjects are and, importantly, aren't right for you. Ac fel y soniais I, as I said, if you don't have the resources already, you can download these from the lobby to complete. Welai chi nôl fan hyn wedyn. I'll see you back here at 3:40.